Catus Maximus here, this time with a review and comparison of the four most common types of electronic tape measure or electronic measuring devices. I've done a review of this Bosch. This is a laser interferometer, so this actually uses not just a laser to point with, but also a laser to measure with. And they're phenomenally accurate and unfortunately pretty expensive from any brand. Then we have the other three types which had the most market prevalence. There's a variety of electronic tape measures, but the four styles I have up here are by far the ones that ever sold the highest number, the most prevalent. And what we have here is a couple of straight line. This one is a ultrasonic measurer. Here we go, if I can get a light. There's actually an ultrasonic transducer, otherwise known as a very high frequency tweeter. That can run anywhere from 30 to 50 kilohertz or more. This works similar to the laser, but it bounces a sound wave off the surface that you're reading and measures the echo to determine the distance. You get a lot less accuracy with one of these. You get less distance with one of these. They use up more battery power and don't last as long as a laser type. And you need a wide flat surface, and you really need to keep this level or square perpendicular to the surface you're measuring. And so that's the biggest issues with these. Otherwise, generally speaking, they are pretty nice. You can measure the size of a room, etc. And this ultrasonic style has been made by, I've seen like 10 different manufacturers. By far the most common type of electronic tape measure. The next one is also a straight line, although I've also seen these in various manufacturers. This is a rolling tape measure. So this works like a computer mouse. It has a guide roller, and then it has a set of large rollers. They're actually connected, as you can see. Inside here, there's just a disc with holes poked in it, and a light flashes through. So just like when you walk into a convenience store and the doorbell dings, that's all this is doing. Is it has a little disc that's blocked. It has periodic slots that block the light, and it just counts the number of tick marks, and it's calibrated for the wheel size. The obvious issue with this is it doesn't know which direction you're going, so if you move it and then go backwards and forward a little bit, it will display, obviously, erroneously large results. These were not very popular because they were really cumbersome. Obviously, you need a large surface. They were more for maybe centering a painting on a wall or something like that. We have the Bosch I just mentioned. This is the most complicated and a surprising take. These weren't very popular because of the complexity and the fact that tape measures get dropped so much that these never really caught on. But what this does is has a system like this where it's counts mechanically, but instead it actually uses holes in the tape, as you can see here, and then it drives a gear. And I believe this one actually is able to keep track of whether you go in or out, which is nice. The other nice thing about this mechanical system is it's calibrated to a physical tape, so this actually measures in pretty high resolution. It's really bulky and cumbersome. They added some features which was odd. They added a voice recorder so that you could take a measurement and then actually record your voice saying, 24 centimeters or 12 feet 6 inches. And then be able to go back and play back your measurements. So at least they were trying. It was an interesting idea, but it didn't really work out so well. The other issue is it uses 2 button cell batteries, and they're tremendously expensive for such a small battery. Let's go and see how this one, show how this one operates. Let me get some batteries in it. The big issue I have with this is because it uses those 2 tiny little cells, they never really have enough current, so this thing always has trouble. It's like a day's use and it runs out of batteries, but it was kind of novelty. What I was impressed by was the fact, and you can barely see there, is it has a metric and imperial display, and it can display in decimal, inches, or fractional, and it really is pretty neat. It actually has 1/16 of an inch resolution, so it's usable. And the other nice thing about it is when you pull it out here, if you go backwards, it knows that you're going backwards. And so I thought that was actually kind of a trick for them to figure out how to do that when it just has one device actually reading the tape measure. And it may not be one wheel. This thing is actually kind of difficult to get apart. But that's what I wanted to show, was just that there is some interesting takes, and really a tape measure that had a digital readout could work, but you would need a little bit better design and engineering and a more compact device that was obviously a lot more durable. And people probably would buy it, to tell you the truth, especially if it had a display like on a 45-degree angle so you could read it from top and bottom. This one also only reads this direction. You're not able to reverse the display if you're using the tape measure this way, which is also a design feature that would be nice. Enough about this one. Let's go and look at these next ones. The next one we'll look at here is this straight line. So it has this deal where you press these little plastic things that come down. You're supposed to put your mark there. Come on, baby. You press this to let it know you're starting. That's our mark. And then you would start rolling it this way. Oh, I see. You have to press. Hello, sorry about that. When it's blinking, then you have to press it. It will start counting. The arrow shows the mark that you started at, so it's going to be measuring from this side. And as you roll, this also has 1/16 of an inch resolution. But what's annoying is that it doesn't always work real consistently as you're rolling it. And the other issues I've had is when you go backwards, and it's actually making fun of me now. I've had issues where when you go backwards, it doesn't actually count backwards, although it's apparently cooperating right now. Such is the nature of digital devices, it's actually working pretty reliably. But you would roll across the surface, and as soon as you got to your surface, you would just mark it on this same side again. So these are kind of funky, but due to their really wide surface area and kind of inconsistent nature, especially the fact that when you're using these around construction and that kind of nature, they get filled with dust, which could have explained the issues I had earlier with this. They just really never took off, never really were very useful, and they weren't particularly well built. So a lot of them, I'm sure, broke within the first few drops. Now we'll take a look at the ultrasonic one here. Alrighty, now we have our ultrasonic one, and these are at least easier to use. They're based off the back. It has a little arrow, measure from base. So wherever you're measuring from, if you're past the surface here, you'll have to measure from whatever your point is that you're touching to the base, because it always assumes that the base is against whatever you're measuring. And then you just press it. And then as you press and hold, it's real time. And you can actually hear it make a little clicking sound. If I could get it to, there we go. Come on. Actually, if it's too close, it'll give you an error. And so it makes a ticking sound. They would make those ultrasonic flea repeller speaker type of things. And that's exactly what you hear, is this really light clicking sound. And it just displays a little laser. So we'll go ahead and get it on a surface that's known against the base of the tripod here. So we get 3 foot 10 inches. Now if we compare that to the laser is obviously much more advanced because it has various modes, like telling it exactly where you want it to measure from the head of the unit, the midpoint of the unit, the back of the unit, and then this Bosch, even though I've done a review, has a nice little feature here where it has a post so you can get down into any kind of recess. And it's nice that it allows you to determine that. So if we take a measurement from the same we get 3 foot 9 5/8. So the ultrasonic in this, actually, if we just go ahead and 3 foot 8 inches. So the laser is going to be much more accurate, even using the same measurement, the same surface. This consistently is reading it being just a slightly closer than what the ultrasonic is. And that's probably the biggest Achilles heel of the ultrasonic, is it needs a wide surface. It's actually just as accurate as the laser, but if it's just really held perpendicular against a flat wall, without any texturing, if you hold it against a piece of siding on your house, the waves and the angles on the siding will actually kind of throw these off. So these are only general guesstimation use, and it's why they never really took off. Was because you just couldn't count on their accuracy. These laser types are actually pretty amazing. They sell, they can range from about $100 or so through several $100s. And what it's separating is part of its durability, whether they're waterproof, and various features. Like this one can do triangulation. It has a little bubble level, so you can actually shoot the distance, and it knows that you're using the bubble, and you make sure that's level, and then you angle it up and you shoot it again, and then it does the trigonometry to tell you how tall something is. It's really neat when you're hiking because you can measure how tall a tree is, all sorts of things. And being a laser, it's just amazing. You can measure something 1 inch tall from many, many feet away. The other huge advantage of the laser is you need something about as large as a 1/4 inch to 1/2 inch, and it can measure it. So you could set up a broom handle in the middle of a room and measure the distance from where you're standing to that broom handle, which also gives these a huge advantage because you can measure complex shapes and just map it out via points, technically, in a very slow manual operation using this device. So the price point sets apart not just durability, but range. There's some of these that will go a 1/4 mile or more, but they won't do it at a 1/16 of an inch. This Bosch, the GLR 225, is 250 feet, but it will do 250 feet at a 1/16 of an inch. So super duper accuracy. These actually can be relied on in place of a tape measure in many longer applications, and many times they'll be more accurate because when you're stretching out a 50-foot or 100-foot tape measure, it's very difficult to ensure that piece of tape is really straight and giving you a really accurate measurement. Any kind of kinks or folds or arcs makes the tape longer than the actual measurement you're taking, where this is just a beam of light. It's absolute. And if you ever see these used, how you know that it's not just using a laser pointer, but it's actually using a laser optical measurement is obvious, because those ultrasonic ones will always have a horn to focus the sound, and laser ones will always just have optics because they're optical. There'll be one window for the actual aiming beam and then an infrared laser that you can't see for the actual measurement. And that's something to mention too, is all these, like this Bosch, when you measure, you hear a physical mechanical relay inside that turns on and off that laser because it's actually pretty bright and it's infrared. So you do have to be aware. You cannot obviously shoot this into your eyes, and you have to be careful using this around job sites so you're not just blasting people with infrared, pretty powerful infrared laser beams that they can't see. So I just wanted to make a quick video about the 4 real common types of electronic tape measures and measuring devices, and just to give people an overview, and to, of course, add to my growing pile of videos. Thank you so much for watching. If you haven't subscribed, please do subscribe. Catus Maximus out.